Hello and welcome to another episode of Anything Arduino. Today I'd like to talk about another sensor that I want to put on my bumper robot, which is starting not to be a bumper only robot anymore. So today I'd like to add the ping sensor, or the ultrasonic distance sensor. So this is a really simple sensor. It sends out ultrasonic, so you won't hear it, but a sound signal that you won't hear. And then it waits and listens for the echo of that sound if it hits something on the way. And when it finds or hears the echo, it will give back that time between the trig and the echo. So it's a fairly simple sensor to connect, because you only have 2 pins. And actually this sensor has been around so long, so it's actually in the examples folder of the Arduino IDE, so we won't have to download any library or anything. So basically we can just dive straight into the code. I just want to say I'm going to place it probably upside down, because I want the pins to be close to the board, and like this or like this. So that's the plan. But as I said, let's just dive into the code. So you find the code under examples and sensors, ping. So this is the code that uses this sensor. So this sketch reads a ping, ultrasonic range finder, blah blah blah, says all the things about what this does. So what you see here, one of the first things is there is actually only 3 pins connected: voltage plus to 5 volts, ground, and signal connection to the ping attached to digital pin 7. So what this means, actually what it is, it's the ping pin 7. So this pin in the loop, instead of doing the pin mode to output or input in the void setup, this is made in the loop. So in the beginning of the loop it makes the pin mode of ping pin to an output. It then sends a ping by making sure the pin is low, sending a high pin for 5 microseconds, and then putting the pin low again. And then, as it says here, the same pin is used to read the signal from the ping. A high pulse whose duration is the time in microseconds from the sending of the ping to the reception of its echo of an object. So here we do a pin mode again of ping pin to an input. So within the loop we change the pin mode from an output to an input over and over and over. And then we get the duration, and then we convert that duration into inches and centimeters just to serial print this to the serial monitor so we can watch this. So let's just begin by checking out this sketch and see how how accurate the sensor is. The example code uses only 1 pin for both the trigger and echo. As you can see on the sensor, there are voltage plus, ground, and in the middle you have 2 pins, one for trigger, that's the you send the trig signal, and then the echo is when the triggered signal is returned, so the echo is sent on the 3rd pin. But as I said, the example sketch uses only 1 pin for both of these, and they switch the pin configuration from being an output when it sends the signal, and then it turns it into an input to receive the signal again. So we are going to use a breadboard because of that. So we can just take a jumper wire and connect these 2 pins like so. And then we take one jumper cable connected to pin 7 according to the sketch. We connect ground, let's do it like this instead, to ground, and plus 5 volts to plus 5. So let's upload the sketch and let's see if this works. So if we just take a piece of paper and we move it down to, let's say, 20 centimeters, try to get my fingers out of the way as much as possible, and we see this is quite accurate, 20 centimeters. We're going down to 19, yes, 18. I am actually amazed how accurate it is. 17, 16, we go down to 10. Oops. Go down to 10. So it shows 9, 10, 7 when we're at 8. So now it starts to get a little bit. So go down to 7, 6, 5. So it's 1 centimeter ahead all the time at this moment. 4, 3, 2. So now it's correct, and 1. Okay, so with this I would say that 2 centimeters is as close as you can get and still get the reading. But another question is, how much does it need to see? So it doesn't see the paper when it's like this. When it's really close, it does actually. Let's take another object. So it does see a really small thing like this. So in the code, let's serial print. I don't care so much for inches, so let's just print duration instead. So let's upload that. So actually the only value I am interested in is the values down here. So 2 centimeters is 137, 140 something. There's 140, so say 140. So as soon as I have a ping that is closer than 140, let's move. So let's add that to our code as well. I've opened up the Arduino bumper robot code from the last episode where we also installed the one shield. So this will work without the one shield as well, and I will make 2 versions of this code. One with the one shield and one without the one shield, for those of you who doesn't have it. All the one shield does in this sketch is gives us ability to steer our robot with a Bluetooth Android device. So if you haven't seen that, go and watch that episode. And there's also 2 other episodes before that for the whole robot thing make. Anyway, so here's the sketch we begin with today, and so we are going to add a few things. Ping sensor variables. So we have the const ping pin from the from this example sketch. And then we are going to need a long ping send time. So this is, I'll explain this in a bit. We don't need anything more than that. We don't need to do anything in the setup. Now in the loop, we are going to just copy all this data from here. Long duration, we don't need that, but we'll clean this up. To there. We need this code. So this is the code we need. Now, this shall only be done once every 100 milliseconds. There's a delay of 100 here. We can't have a delay in our sketch, because if we do, then the motors will go really slow, because then they will only move 1/4000th step of a full rotation every 100 milliseconds. So therefore we have that long ping send time, which we'll do this with. So if millis, that is the millis seconds that has gone by since we started our Arduino, and this will run for 50 days before it is reset, so lots of time. So if millis is larger than ping send time plus 100 milliseconds, so if 100 milliseconds have gone by, then we will do this. And we close that. And first thing we do is we also do ping send time equals millis. So we reset the ping send time timer. And after we have checked we've gotten the duration, so we said 140, right? Let's leave it at that. So if duration is less than 180, and then I also try this out, and sometimes I get a null or 0 reading value. So if duration is less than 180 and duration is more than 100, then it's still a reading, but it's not 0. Sorry about that. Then we are going to, so here is where we're going to turn left or turn right. And right now I'm going to rewrite the functions for turn left and turn right, but for now they turn 45 degrees every time, so we're just gonna call it twice. Also, I want some kind of randomness in this, so we are going to add one more if statement in here. So inside this if statement, let's do like that. So if duration divided by 2 2 equals 0. Then, so if duration divided by 2 equals 0, this means that it's an even number. Then we will turn left. Turn left twice, remember, for 90 degrees. If it's not, it is an odd number, and then we will turn right. Twice. There. And this is it. With this, we should not need to do any more with the code, and it should work as it is supposed to. So let's upload this into our Arduino. Let's verify this, and then we are good to try it out. Remember the brackets on the function calls for turn left and turn right. I forgot this here, but corrected this afterwards. I know I see this a lot, but hot glue gun, once again, is your friend when you want to do these kinds of things. So just to make this easy, I'm just going to place it on top here, actually. So just a bit of glue, like that. And then we place this. Try to be as close to 90 degrees as possible. There. Perfect to build small things with, don't you think? Okay, for those of you that were a bit more alert than me, I did not think this through at all. So I actually have to remove this one because I'm blocking both the USB port and the power port by placing it here. So we are instead going to place it here and put a bit of glue there and there instead. Now some of you might argue that now the bumpers have no function and why should I keep them? And that is true. They coming straight ahead to something, we will never touch it because the ping sensor will sense this before. But if there's a wall here, the ping sensor will not sense it while we go into the wall at, say, a 45-degree angle. And then the bumpers will sense this instead and turn and go another way. So even though we have the ping sensor, I still want the bumpers for those kind of situations. And this is also because we are getting really close to the sensor before it triggers a turn. So here's a small circuit that I hope we can go around without problems. So the bumper will work from time to time and the ping sensor will work. There goes the ping sensor and there was the bumper. And you know the difference between the two depending on how much they turn. If they turn 90 degrees, it is the ping sensor, or else it is the bumpers. And also I'll connect my Android device and turn that way a bit as well. So we also take out our Android device, which makes us be able to turn this. It gets stuck here. So now this robot has 3 ways of moving, either by turning, by me, or bumping into things, or sensing something in front of it. So either it's probably a very confused robot. Also, I might get a back command so I can manually back it up as well. Okay. So this concludes this episode of Anything Arduino. I've added another sensor to the robot, in this case the ping sensor. And I hope you've got a grasp of how easy it is to work with the ping sensor and adding it to your robot project, for example. And actually how accurate it was. I didn't think that. It did not read some from time to time. I'm not sure that is why that is. I'll look into that. So this is a stuck mount of the ping sensor. It won't move. I've seen others where they mount it on a servo so it can look all the time, look where it should go. I wanted this just to make sure it doesn't go into anything, and actually it can see, if it goes into a pen straight ahead, it will see the pen and it will stop and move 90 degrees and go someplace else. So that is what it's for. I might add another ping sensor that will turn around and see what else is around and where it can go. But right now, I don't know, it seems fidgety or something, that at least you should always have eyes on the road straight forward, and then have another one in that case to look on the sides for where to go next. So I hope you liked this project, and if you did, do a thumbs up. And if you do like these kinds of projects, then please subscribe to me, to the channel, where I do a lot of these things. I can't talk today. And if you want to know something about this project, or have any questions or suggestions and stuff like that, leave them in the comments and I'll try to answer. Until next time, take care, bye.